So let's try an example. I want to compute the line integral, right, the vector line integral of f dr, where f is the vector field x plus y comma y, and c is the quarter unit circle oriented, CCW stand for?
Counterclockwise.
Oh, nice. Good.
Concealed carry weapon.
You have a guess.
All right, so how do I do this? What do I need?
Do the slope fields and need
Okay, I need a slope field, got a slope field. I need a curve,
the need drive.
do I?
Not really. You're given the function, so.
I probably don't have to draw it, but I could. So we already drew this one
Yeah,
actually.
that's
Do you guys remember what this one looked like?
Yeah.
Yeah.
It's
Water.
kind of this thing.
Mm-hmm.
Okay, and C is the quarter unit circle.
So we're doing 1/4 of it oriented counterclockwise. It's going to be the second quadrant, isn't it?
Okay. The first quadrant quarter unit circle? How about that?
Oh, first quadrant. Okay.
So here's the world, or the XY plane. Quarter unit circle. What's that? This thing.
First quadrant is this. Yeah.
This deal?
It's going that way too.
Okay, and I need to go that way.
Okay.
Why is the orientation important?
Because you'll get a negative.
Yeah, you flip the sign, right? So here, remembering that the current was kind of going this way, right? This is probably swimming against the current. This is probably going to be
Okay.
negative, right? I'm going to get negative help from the current. Okay.
If you have like a curve going one way and the vector field is going exactly the opposite way, would this give you the magnitude or the length of that but negative? Like is the maximum value for this going to be the length of the curve?
Not necessarily. If the current is extremely strong,
Oh, okay.
right?
Okay.
If the current is always
So vectors
flowing
are
with
maximum.
speed 1,
Okay.
then yeah, the maximum value is going to be the length of the curve. The minimum value is going to be minus the length of the curve. But if your vector field has some other flow, speed other than 1, this could of course be bigger or smaller. Let's see. Points?
0 to pi over 2.
Oh, cool. You have already moved to a parameterization, right?
But would we not want to just do, well, I guess it's not assuming it's a unit circle.
No, this is supposed to be a unit circle, quarter unit circle.
Okay, then, oh, yeah, yeah, so
So-
can we not use like, X and Y coordinates?
Yeah, I probably can't use X and Y coordinates because I need this to be a one variable, right?
Yeah.
Okay.
But what are your X and Y's in terms of one variable for the unit circle?
Well, r cosine theta and r sine theta.
Okay, so I'm going to think about this thing as R of theta, right? And this is going to be,
X
What
would
was-
be cosine theta, right?
yeah, why did I drop the R? Cosine theta?
Because
Sine.
Because it's 1.
Yeah, because it's 1, because it's the unit circle I'm talking about, right?
Okay.
And the second coordinate, the Y, is
Sine theta.
sine theta. Okay, so I just remembered the standard parameterization for a unit circle, right? Does it go the right direction?
Yeah. No. Wait. Yeah.
Right? It goes from theta 0 to pi over 2, it goes
Yeah.
this way.
Yeah, that's possible.
Okay, if I wanted to do the other one,
Sine would be negative. Right?
yeah, then flip the
Yeah.
sign on something, or maybe just flip the sign on the answer you get, right? Okay, so I want to run R of theta from 0 to pi over 2. What else do I need?
You also need the derivative of r theta, right?
Okay, perfect. So I want to just start by writing, okay, the idea I want to do is the integral over C of f dotted with dr. And of course, the execution of this idea is going to be the integral from
0 to pi over 2.
0 to pi over 2. Good.
F of R of theta
F of R of theta
dotted with
R prime theta.
dotted with R prime of theta d
T. Oh, D
Theta.
theta.
theta. Good. Perfect. Cool. All right. So now I know at least one of those pieces, right? So this is the integral from 0 to pi over 2 of f of
Cosine
Cosine.
theta. Sine.
cosine theta comma sine theta. And I need to dot that with
Negative sine theta.
cosine theta.
negative sine theta comma cosine theta.
D theta.
And then this needs to be d theta. Perfect.
And we need to plug the sine into the original one.
Good, perfect. Go plug cosine and sine into your function f. Wait, I said function. What did I mean?
The
Vector field.
Yeah, f's a vector field, right? So I need to take cosine sine, I need to plug them into that vector field. So I'm going to get the integral from 0 to 2 pi, or 0 to pi over 2 of
cosine
Cosine
plus
plus
sine, comma,
cosine theta plus sine theta, comma,
sine
sine theta. Good. Dotted with
negative sine theta, cosine theta.
negative sine theta, comma, cosine theta, d theta.
Got 'em.
Yeah.
Okay, so then do your dot product. So you got the integral from 0 to pi over 2 of
Cosine.
theta.
Well, negative. Yeah. Cosine theta.
Negative sign.
Negative sine theta.
cosine theta what negative sine theta?
Negative cosine theta,
Times.
sine theta.
Time.
Yeah.
Okay, so
Negative cosine theta.
I
Sine.
need to take this thing and multiply it by this stuff, right?
Yeah.
Oh, okay, I'm thinking of the product group.
Yeah, it is inner product. You need to multiply the x coordinates, multiply the y coordinates, and add, right? So multiply the x coordinates, I got negative sine theta,
Cosine theta.
cosine theta,
Minus sine
Sine
theta squared.
minus sine squared theta. And then I got
And you add cosine sine theta.
add cosine theta sine theta,
Theta.
and I'm d theta-ing this whole thing.
But you can get rid of the cosine sine theta.
Cool, the sine cosine bits cancel.
That's easy. Sine squared theta.
And
So I got here the integral from 0 to pi over 2. Maybe pull the negative out front.
Yeah.
And then so I've got minus the integral from 0 to pi over 2 of what?
Sine squared d theta.
Sine squared theta d theta.
So the cosine squared theta, or cosine. Why are they gonna-
That was
1/3.
What?
Where'd the 1/3 come from?
Oh wait, no.
I had a sheet for this, but I keep forgetting it at home.
Okay, so I got negative the integral from 0 to pi over 2. And I gave you a clue?
U substitution.
No.
It's called tables and I have it.
No. Half angle identity. Remember the one we were struggling with yesterday when we tried to do
1
the
minus
rotated
cosine
thing?
2 theta over 2.
Perfect. 1 minus cosine of 2 theta, and I'll put the over 2 out here. So I got minus 1/2 the integral from 0 to pi over 2 of 1 minus cosine of 2 theta
D theta.
d theta.
And then we could just separate.
And you could notice that you're integrating cosine from 0 to
0 to.
Oh, 0
So it's just
to
gonna be-
pi.
Oh, so you could separate those intervals.
yeah, so I could notice that I'm integrating, yeah. So I could separate them into 2 pieces, right? I could
Yeah.
do minus 1/2 the integral from 0 to pi over 2 of 1 d theta.
And then just
That one's gonna be pretty chill, right?
just Cosine
Yeah.
theta.
And then I've got plus 1/2 the integral from 0 to pi over 2 of cosine of 2 theta d theta.
What do you mean minus?
No, because minus.
Oh,
We got a minus
gotcha,
up here.
gotcha.
And this, you can notice, cosine of 2 theta, that goes through a full half period.
Full.
Just go to pi over 2.
Yeah.
Cosine looks like this, right?
Yeah. But then it's multiplied by 2.
So this is from 0, pi over 2, and pi.
Yeah.
So between 0 and pi,
It's just gonna be 0.
it's going to zero out, so this piece will just drop. Okay, see that?
Mhm.
Little u substitution will get you there if you don't see it.
No, we're just theta.
And then this one's, so I got -1/2 theta evaluated from
We're supposed to integrate that first,
0 to pi over 2.
then,
So you get negative pi over 4.
Yeah.
Perfect. So I got negative pi over 4.
weren't we supposed to integrate that first and then?
This thing?
Yeah.
Yeah, you can integrate it or you can notice that it's going to cancel. Cosine of 2 theta goes from 0 to pi over 4 to pi over 2. And it is positive
Yeah, but you're
You're just
as
taking
much
the
as
area.
it's negative. So the area under it's going to be 0.
So what's the
Or you can integrate it and evaluate and it'll still be 0.
So what does the negative pi over 4 tell us?
What does the negative pi over 4 tell us?
The vector field purpose.
Yeah.
Yeah, I had to work against the vector field, right? Negative pi over 4 units. You guys see that? Or the vector field hindered my effort, negative pi over 4 units. Or I had to expend pi over 4 units worth of fuel to get from here to there.
That's what I was gonna ask, like,
But
what
if-
would be real world
Yeah, real world,
units? I understand a scenario.
yeah, so real world units would be how much charge are you gonna lose out of your electric car? Assuming that your brakes reclaim power at 100%. You guys see that? Of course, electric cars' brakes don't reclaim power at 100%. It's more like 60 or 70. But yeah,
Okay.
60 or 70 is worlds better than 0, which is what your conventional car reclaims, right?
Yeah.
Or your motorcycle. Which is sad because your brakes have a lot of horsepower. It would be really nice if you could harness that. Cool. Questions, things?
Yeah, I just have a comment on question. The very beginning, like cosine is x and y is sine. That's just because it's a circle. And that's always going to
Yeah.
be. Okay.
Yeah, that's me
For
trying to
y.
look at, okay, here's a circle, right?
Mhm.
This thing is really x squared plus y squared is 1.
Yeah, that's what I think of, and then I see the cosine of
Yeah, so I want something that's squared plus something else squared is 1 and goes around the circle.
it. Okay. Because cosine squared is theta and sine squared is.
Yeah, it's really me exploiting the definition of cosine and sine. Or the Pythagorean theorem, or something you vaguely remember from trig class.
Yeah.
Cool. Or that's how circles work. It's also a acceptable thought. Other questions?